In this video, we will discuss static and kinetic frictions and how they come into play in problems associated with Newton's second law. Now, it's important to recognize that static and kinetic frictions, they are forces, meaning they are vectors and therefore have magnitudes and directions. In solving a problem associated with static and kinetic frictions, it's important to know when and how they act. So we shall address these shortly. Let us look at static friction. Now, we usually denote static friction with F subscript S. Now, let's say you have a box, a weight of some kind, and it's resting on a surface. Now, static friction is the type of friction that acts between this box and the surface when there is no motion, or I should add, no potential motion between these two surfaces, namely the surface of the box and the surface of that floor. So when this box is not doing anything, it is just sitting there, the static friction is zero. So when does the static friction comes into play? Now, to answer that, let's look at this inequality. Now, static friction is given by an inequality, not an equation. Now, this mu sub s is called the coefficient of static friction. And n here is the normal force that is being exerted on this box in a 90 degrees direction with respect to the surface. So the value of static friction will always be less or equivalent to this product. So this product is therefore the maximum static friction that can be exerted on an object such as this one. Let's give an example as to how this inequality works. Now let's assume that coefficient of static friction between this box and this surface is 0.5. Just an example. The weight of this body, the box, is, let's say, 50 newtons. So that means the normal force is also 50 newtons. So the normal force acting on this box is 50 newtons. That means the maximum static friction in this case that can be exerted on this box is the product 0.5 times 50, which is 25 newtons. So according to this inequality, the value of static friction can vary anywhere between 0 all the way to a maximum of 25 newtons. When is it 0? When is it 25? Now let's assume that we start to push this box rightward. Now before we start pushing, let's say we are not doing anything to it. So there is no potential motion. So when there is no potential motion, the static friction is 0 because there is no effort to try to move this box. Now let's say I start to move this box to the right with a force of 10 newtons. This is the force that I exert. Immediately, the static friction will start to kick in. Now, because the object is not moving, the static friction will be exactly 10 newtons. And then, let's say I increase the forward force to 15 newtons. The friction will then go up to 15 newtons, and so on. And then when I get to, let's say, 25 newtons, the static friction is maximum at that time, which is 25 newtons, and the object is about to move. The moment I exceed 25 newtons to, let's say, 25.1 newtons, the object will start to slide forward. And that is the time when static friction will cease to exist. It will become 0. If it becomes 0, is there any friction left? Well, that brings us to the second type of friction called the kinetic friction, which acts when there is motion between the two surfaces. So now when the object is moving, let's say to the right, since the static friction is no longer there, the static friction will be taken over by this kinetic friction, and there is a forward force of, let's say, 26 newtons. Now, how do we compute this kinetic friction? In a similar way, but now kinetic friction is defined by an equation. So this mu k here is called the coefficient of kinetic friction. And this capital N is the normal force exerted on this object in an upward manner, 90 degrees to the surface. Now, like coefficient of static friction, coefficient of kinetic friction is a dimensionless quantity, which means it's a pure number. As you can easily see from this equation, the left-hand side is a force. The right-hand side, which multiplies the coefficient, is also force, which is a normal force. So when you take the ratio of F sub k over N, you'll get mu sub k, which is the coefficient of kinetic friction, and that tells us that coefficient of kinetic friction is a quantity without any units. It's a dimensionless quantity. So to sum up, kinetic friction is the type of friction that acts when the object is moving, or when there is relative motion between the object and the surface. Another thing, just to summarize, is that static friction opposes potential motion, meaning it always will try to prevent an object from moving, whereas kinetic friction opposes motion. It acts when object is moving and therefore will always act in a direction opposite to that of the motion. Let's look at the following problem to understand the concept of friction better. A person is pushing a 50 kg box horizontally with a force of 200 newtons across a level floor. If the coefficient of kinetic friction between box and the floor is 0.3, calculate the frictional force, meaning the kinetic friction force, and the acceleration of the box. Let's start by sketching a free body diagram. So this is a 50 kg box. So its weight is 50 times gravity. And then there is this normal force. The normal force is the same as weight in this case, which is 50 times gravity. There is a forward force that is moving this box, and that is 200 newtons. And obviously there will be an acceleration, which we'll calculate in part B. And of course, do not forget, there is this kinetic friction. Now this kinetic friction actually acts here on the surface, but for clarification purpose, I sketch it a little bit above the ground. Before we calculate the acceleration, we first need to know what the frictional force is. Now there's motion involved, so the type of frictional force that we are to compute is kinetic frictions, which is coefficient of kinetic friction times the normal force. The coefficient of kinetic friction is given, which is 0.3. The normal force is the same as that of weight, which is 50 times gravity, and that will give you 147 newtons. Now, having found the friction, we can compute the acceleration of the box. Now, from Newton's second law, the net force is in a forward and a rightward direction, and that is given by 200, the forward force, minus the kinetic friction, which is 147. So 200 minus 147 is 53 newtons. And since net force also equals to ma according to Newton's second law, we can equate that 53 newtons to mass times acceleration. Mass is 50, acceleration is a, and you can calculate a to be 53 divided by 50, and that's going to give you 1.06 meter per second squared, and that solves the problem. Let's look at problem 2. Given that the coefficients of static and kinetic frictions between the 4 kg box and inclined plane are 0.5 and 0.35 respectively. If an upward force of 60 newtons, as shown, is exerted, calculate the acceleration, if any, of the box. So first, of course, you have to sketch the free body diagram. But in the free body diagram, you have to sketch the frictional force. Which one do you use? Is it static friction or kinetic friction? So that is the main idea of this problem. How do you find out which friction is acting on this mass, on this 4 kg box? So first, let's just label all the forces acting, and then we'll come back to what kind of friction is acting on this box. So the 60 Newton force is shown. The obvious one is, of course, the weight, which is 4 times gravity. Okay. And there is a normal force, N, and there will always be a frictional force. Let's call it F. We will label accordingly whether it's static or kinetic friction. Let's not forget the 2 components of the weight. One component is perpendicular to the plane, which is 4 times gravity times cosine 30 degrees. And the other component of the weight is the component that is pulling it down parallel to the plane, which we can label as W parallel, and that is 4G sine 30 degrees. I am writing these 2 quantities in red just to show you that they are not independent forces, and they result from the weight 4G. The value of this perpendicular component is 34 newtons. The value of that parallel component of that weight is 19.6 newtons. Now let's first compute the maximum static friction that this body is subjected to, that can be subjected to. It is mu sub s, the coefficient of static friction, times the normal force. The coefficient of static friction is 0.5, it's given. The normal force is the same as the component of weight perpendicular to the plane, which is 34 newtons. So that gives you 17 newtons. Why are we doing this? Well, just to check if there will be motion up the plane. You see, the maximum static friction is 17. The component of weight that is pulling this weight down is 19.6. When you sum the 17 to 19.6, it is still less than 60 newtons. So that means, in this case, the object, the box, will move up the plane with some acceleration. So that means the friction that acts on this body must be kinetic friction, because we have shown the object to move, namely up the plane. So let's label the acceleration to be in an upward direction. Now we are ready to solve this acceleration. The net force on this object in an upward direction is 60, the forward force, minus the 2 forces that's pulling it downward, which is the kinetic friction plus the component of weight parallel to the plane. So Fk plus W parallel. So what is kinetic friction? Kinetic friction is mu k times the normal force. So mu k is 0.35. The normal force is 34, that is that, plus W parallel, which is 19.6. Now, why is it that normal force is the same as the component of weight parallel, perpendicular to the plane? It's because in a direction perpendicular to the plane there is no motion, the net force is 0, so the normal force must be the same as the component of weight perpendicular to the plane. Now let's compute this line here. That's going to be 28.5 newtons. Now from that Newton's law, we know that net force equals mass times acceleration, so 28.5 equals 4 times a. So when you solve for the a, you get 7.12 meter per second squared. So that is the acceleration of this object, and that solves the problem. I hope you find the content of this video useful. If so, please consider subscribing to this channel. It can certainly help the channel grow. Thank you for watching.